We're going to look at simplifying complex rational expressions. What makes something a complex rational expression? It's really a fraction within a fraction. Here's an example. Here's a fraction. The numerator and the denominator both, in this case, have fractions. One or both, if they have fractions, then it makes the overall fraction complex. Okay, there's a couple ways to solve these, but we're going to stick to a method that you really already know how to do. And I'm only going to teach you one method rather than two to not over confuse it. So here's what we know. If we have it down to a single fraction on top and a single fraction on the bottom, we can rewrite this as a division problem because that's what it is. It's a over b, the numerator, divided by the denominator, c over d. But we know with fraction division that we can turn it into multiplication by changing it from division to multiplication, and then flipping the second fraction. Okay, so let's take a look at some examples with just numbers, and then we'll go ahead and we'll work some that have variables. So here's a very simple case, just like I showed you up here. I'm just going to simply rewrite this as a division problem and then turn it into a multiplication problem by flipping the second fraction, cancel the common factor, the 3 that's in 3 and 9, leaving me a 3, and then 1 times 3 is 3, and 1 times 5 is 5, so here would be the answer. A slightly more complicated case would be this, where I've got two numbers, one a fraction, one a whole number, and in order to use this method, I need to get this into a single fraction and this into a single fraction. Well, all I have to do is get a common denominator, and I can combine the numerators. So the common denominator is 5. So if I multiply the 1 by 5 over 5, the common denominator, what would I end up with? I would end up with 5 plus 4 over 5, the common denominator, which would then simplify to 9/5. On the bottom, common denominator would be 7, so I'm going to convert 2 to a common denominator of 7. That means I'm missing a 7 in the denominator. I multiply by 7 over 7. That would give me 14 plus 2 over the common denominator of 7, which simplifies to 16 over 7. Well, now I'll rewrite it as a division problem, a classic looking division problem, which I turn then into a multiplication problem. And nothing cancels, so I get 63 over 80. A slightly more complicated version with just numbers, and if you can do it with numbers, you can do this with variables. Okay, so here's two fractions in the numerator and denominator. Common denominator of these would be 42. You could see, if you did the prime factorization and so forth, our method, you would discover that 42 is the LCD. So to convert the numerator to 42, I would have to multiply this by 7, because 6 times 7 is 42. And if I do the denominator, I do the numerator, so I'm multiplying it by 7 over 7. Okay. The second fraction, I have to multiply it by 3 to get the common denominator of 42, but I have to multiply it by 3 over 3. And when I multiply that all out, I end up with, this is 7 over 42, this is 9 over 42, which combines to be 16 over 42. So there's my goal, a single fraction on top. Likewise, on the bottom, my lowest common denominator of 6 and 10 is 30. Okay, so I'm missing a 5 factor to make this a 30, so I'll multiply it by 5 over 5. That gives me 35 over 30. Here I'm missing a 3 to get a common denominator of 30, so I'll multiply it by 3 over 3. That gives me 21 over 30. Now I add the fractions together, and now I'm down to a single fraction, which I can then turn into multiplication by flipping the second, cancel common factors, and then multiply to get my answer. Okay. Okay, now let's work with some variables. But these problems are very similar. They just contain variables. So here we really have a situation where we only have a single factor in the numerator, x over x squared minus 36, and in the denominator it's a single factor. So we'll turn it right into a multiplication problem by turning it to multiplication and taking the reciprocal of the denominator. As always, I'm going to factor, so the numerator x squared minus 36 is a difference of squares, and I'll cancel my common factors as I have done before. The only thing left in the numerator is x, and the only thing left in the denominator is the x plus 6 times 7. No other cancellations, so that would be simplest form. Okay, let's take a look at a slightly more complicated. Here this was a single fraction to start. Here I have two terms, one of which is a fraction. So my lowest common denominator in the numerator is t. So 1 needs to be multiplied by t over t. And then what does that give me? That will give me t plus 5 over the common denominator of t for this. In the denominator here, t squared will be my common denominator. So I would have to multiply 1 by t squared over t squared. And that would give me t squared minus 25 over the common denominator of t squared. Now I am down to a single fraction in each. Okay, so what do? Keep the first one, turn the second one its inverse and use multiplication, and then as always I'm going to factor everything that I can. And so the t squared minus 25 that ends up in the denominator is a difference of squares, so I factor it. The t plus 5's cancel. The 1t here can take and cancel with one of the t's in the t squared term, leaving me only a t in the numerator, and the only thing left in the denominator is the t minus 5. Okay, the most complicated case, try to hang with me. You can always stop and pause this. Don't look ahead. I'll just kind of explain this and I'll keep it all uncovered. But again, here we have two fractions. We want to simplify the numerator, simplify the denominator into single fractions. Well, here I've got two different denominators, so the common denominator will be x times x minus 1. Well, here what am I missing? I'm missing the x term, so I'm going to multiply this by x over x. That gives me the 6x. Here I'm missing the x minus 1, so I'll multiply the 11 by the x minus 1. All of that over the common denominator. If I clean it up here, do the distribution, I end up with 6x minus 11x plus 11 all over x minus 1. This would then further simplify by combining like terms to minus 5x plus 11. All of that over x times x plus 1. So that's the process of getting the numerator all the way down to a single fraction right here. Now we'll do the same thing with the denominator. Again, the common denominator is x minus 1. The 13 is missing the x, so I'll multiply it by x. The 11 is missing in the denominator the x minus 1, so I'll multiply it by x minus 1. All of that is over the common denominator of x minus 1. Do the distribution. I'm going to get 13x plus 11x minus 11. All of that over the common denominator. If I simplify that out, I'm going to end up with 24x minus 11 over x minus 1. Well, I'm going to go ahead and turn this into multiplication. I'll take this and flip it so you can see the 24x minus 11 is in the denominator. The numerator is now x minus 1. Cancel common factors. So these x minus 1s, these common denominators cancel each other out completely. What am I left with? These, there's no factorization, so 5x plus 11 in the numerator minus 5x plus 11. The denominator is 24x minus 11. You may have to watch that again This is the most complicated case. But if you're neat and you keep track of what you're doing, it shouldn't be too terribly difficult.